So after talking about parkans, we're going to slowly move our way up in terms of complexity to the next couple lights that we use most commonly in the theater. Again, these lights are not the only lights used in theatrical settings, but the ones that you will probably see most commonly across the board in various theatrical houses. This light here is called a Fresnel. I know it looks like it's spelled Fresnel, but it's French, and it is pronounced Fresnel. It's called that because it was named after the French physicist Augustin Jean Fresnel, who developed this lens originally for lighthouses. They were looking for a way to get a large aperture of light with a very short focal length, meaning that the distance from the part that emits the light to the actual lens is very short. That has then a long beam of light, wide beam of light, that is able to be produced from this lens. So originally, these lights were not used for a theatrical setting. Yet another great example of theater taking something from another industry and repurposing it for their own uses. These lighthouse lamps used to be much, much larger, and I'll have a picture of them in the next slide. But the theatrical ones are rather small, usually 5 to 6 inches across for the lens. But obviously you see all of the same hardware up top here on the clamp and various other portions that holds it to your batten, as well as your instrument leads there and your adjustment portions of the fixture. So those all stay the same. But there are a couple things that are slightly different on here as opposed to the parkan. The little button that you see up top, that is the lens release. You see this portion on the front is actually hinged at the bottom here. There's a little hinge there, and this section will then open up, and the lens is placed behind that. Kind of sits right into it. So that little button up there, this little guy, releases that hinged plate to open up if you need to change out the lens, if it's broken, or if you need to clean it, or whatever else. That lens release area also serves as a color frame holder. Sometimes you have Fresnel lenses that have the same little clips on the outside, the way that a parkan would, so that a frame can then slip right into the top there. In this case, you would basically combine the lens and the piece of color filter or gel in that same area where you would slip the lens into it and then slip your color in front of it. So you can get either version on a Fresnel fixture. This one just happens to be the one without the actual brackets and more of a combined feature. The other thing that we have on a Fresnel fixture that is different from a parkan is the focus adjustment knob. So this knob actually changes the focus of the beam of light, meaning that it changes how wide the light coming out of the front of the fixture is. If you move this knob forward towards the front of the fixture, it makes the beam more narrow, while if you move it towards the back of the fixture, it makes the beam more wide. The way you operate this is you actually unscrew that knob, and then you are able to slide it back and forth along the external part of the external housing of the fixture. What you are actually doing when you move that knob is, as you'll see in the next slide, you are actually moving the lamp. That knob inside is attached to the lamp that is sitting there and shining towards our lens in the front, and you are moving that lamp farther or closer to the lens. And by changing the distance between the lamp and the lens, you are actually changing that focus point, and how far away or how close that that focus point is to the lens changes how the beam of light will appear coming out of it. And in the next slide, I will also get in a little bit on how the lens itself actually works and why moving that lamp back and forth makes a difference. within that focusing distance. As far as features of the actual fixture go, that's pretty much it. Those two additional things, your lens release and your focus adjustment knob, are really the only two additional things that you have on a Fresnel that are different than a par can. Obviously, we have a different type of lens, and we will talk about the fact that we have a different type of reflector as well, but in terms of adjustments that are able to be made to the fixture, those are the only two differences between those fixtures. Here we have a very large picture of a massive Fresnel lens that is installed in a lighthouse. I believe this lighthouse is in Florida, though I'm not 100% sure where. But you can see the actual construction of this lens. Here are actually circles of glass rather than one complete lens, but this portion up here is a solid Fresnel lens. It has a stair-step pattern. Just going to throw this image over top here. You can see the difference between a regular old convex lens and the Fresnel lens on the bottom. Your conventional convex lens has a curved outside and a flat back, where you can see the Fresnel lens, and this is a cross-section, has this kind of stair-stepped pattern to it. It's still a little curved, but it goes down to the center portion, and then the other side matches it. And if you were looking at this from head-on, it would look like rings, concentric rings, going down smaller and smaller until it hit this center section. But essentially, what's happened here is that these sections, these red areas, if you take the conventional lens, the red areas have been removed, quote unquote, and it is this green area here, that is then left behind, and each of these areas is dropped down, all right, to create this. So this area right here, you can see, is the same as this. So taking out this area, the red area, leaves the green area, which then becomes the Fresnel lens pattern. That's not actually how they're manufactured. I will post a link to a really cool video of how a Fresnel lens is manufactured. It's actually the replication of a large Fresnel lens in Florida, similar to the picture I have here, but it is usually not done by necessarily cutting portions out of a conventional convex lens, but that's the idea, that you're getting the same type of focusing power, just in a different pattern. Now getting into the actual optics in how the Fresnel lens works once you have that stair-step pattern established. So like I said, if you look here, that focus knob at the bottom of your fixture, you can see our lens at the front, and that focus knob is actually attached to a base that has your lamp and your reflector attached to it. And that lamp and reflector component then moves back and forth, either closer or farther away from your lens, which is in a fixed position at the front of the fixture. The thing to note about this reflector is its shape. We talked previously about how a PARCAN stands for parabolic aluminized reflector, and therefore the reflector itself is a parabola shape. The shape of the reflector in a Fresnel fixture is a sphere. Now obviously it's not a full sphere, but if you continued this shape as far as it would go, it would actually become a sphere. So it is considered a spherical reflector. And of course this is going to have different properties in terms of how the light is reflected based on that shape. If you look at the arrows that we have here, these beams of light, the stuff that's shooting out towards the back, obviously hits the reflector and is reflected back towards the front of the fixture. In this case, you have light that is bounced to the reflector and then bounced immediately back to the same focal point that that filament is creating. So it is bounced back to the same point that it was originally given off to. So it creates a very tight focal point. You don't have any light that is bouncing off in all these strange directions the way we did with a parcan. So we needed that parabolic reflector to kind of hone in all of those different beams that were being a little crazy off the back. With this, all the beams that are bounced to that back reflector are brought back to one specific point, and because it's all being emitted from the same point, it is then being shot back to that point, which means that this tight focal point allows the lens to be more efficient. So as that light is coming out, it then gives it this nice solid beam of light. And as we change the distance between our lamp and our reflector, as we did up here, it then changes where that focal point is in relation to the lens, and therefore the beam will become a little bit narrower or a little bit wider. If you look up here, you can see the difference in the way that the light would change if you put a light source on the other side of a Fresnel lens. So if we put it on the stair-step side rather than the flat side, you can see here, this is how it would be if it was in a flat side, the way that our fixtures do. We start from a very tiny focal point and it is brought out into a beam of light. However, if we put it in the other side, all right, we'd have a very wide beam of light that would then be put out into a even wider, less controllable beam of light. And you can see here again, focal point going into the flat side and out the stair-step side. We have a nice, even beam of light. But if we flipped it around, we'd have something going a little bit crazy, a much wider, uncontrollable beam. So it is important to note that just because these lights might have different types of lenses and different types of reflectors, they aren't just haphazardly put together. It's not like someone suddenly realized that a Fresnel lens would be more efficient than the type of lens in a parcan and decided to switch it out. Someone actually went through and thought about the fact that you would need a much more focused beam of light to make a Fresnel lens work. So they created a spherical reflector instead of a parabolic one. And as time went on, we then eventually will get to ellipsoidal reflector spotlights, which is the next type of light that we'll talk about. But the type of reflector and the type of lens and that lens position and the position of your lamp and everything else in there is very carefully engineered to make sure that everything is going to work together properly. So, our advantages to Fresnel lighting. The first one is that you have the capability to adjust that beam of light. You can make it wider or a little bit thinner based on where you place that focus knob, where you place the focus point from that light. So you have a little more flexibility in terms of what you can do with that actual light. And similar to the parcan, it is a very simplistic piece of equipment. The light bulb and the reflector are attached to a base that can be easily removed and repaired if need be, as well as the fixture itself. Again, the metal container is relatively simple, a little more complex in terms of being compared to the parcan, but in terms of other lights, it's an incredibly simplistic piece of equipment. These again are good for area lighting, but because you have the ability to adjust that beam of light, you can use them for specials, meaning if you have a specific area that you want lit, you can dedicate a Fresnel to it to allow that area to be lit on its own, because you can adjust things a little bit with them. They're good for area light as well as good for special lighting. As far as disadvantages go, unfortunately we run into some of the same problems that we did with parcans. Other than the fact that you can change the beam width a little bit, there's not a whole lot else that you can adjust with them. And even the ability to adjust that beam is rather limited by the depth of the actual fixture. You can only go as far back as there is room within the fixture housing. So great that you can move it, but it is not necessarily the most wide range of adjustments that you can make with it. Second disadvantage is that the Fresnel lenses themselves are rather hard to manufacture. They are finding ways to manufacture them better with improved technology, obviously, but as you get bigger with them and get more complex with the fixture itself, you end up with more and more expensive and more difficult to find lenses when it comes to Fresnels. Lastly, we have our ellipsoidal reflector spotlight. This is what is considered to be the workhorse of the theater lighting world. It is an incredibly versatile unit that has a whole lot of different components to it that allow it to do different things that we will explain in a moment here. But this is probably the most common type of fixture you will see in a theater. The first feature we'll hit on is actually a similarity to a Fresnel fixture, and that is the fact that an ellipsoidal reflector spotlight actually also has an adjustment knob, a focus adjustment knob. Rather than being on the bottom of the fixture, for at least this type of ellipsoidal light, it is located on the top of the fixture here. Unlike the Fresnel, where that adjustment knob is physically attached to your lamp, in this case, your lamp is going to be at the back of the fixture there, and what this does is actually moves the lens. Inside there are lenses, two lenses for an ellipsoidal spotlight, and this focus adjustment knob moves one of those lenses. It'll move it forward or backward. So you unscrew that little knob there, and the whole front part, this whole front part of the fixture, if you see how that is slightly inset into the other part, that's called the barrel. And that barrel contains one of the lenses. So unscrewing that allows you to pull the barrel out or push it back in, depending on how wide or narrow you want that beam to be. And this allows a much greater variety of beam widths based on where that position is than the Fresnel lens would offer. You can move it, there's a much greater distance that you can move it, and it also, because there's two lenses, creates a wider variety of those beam widths. And of course another similarity is your color frame holder. Once again located on the front of the fixture, those little brackets, three of them that are on the sides and on the bottom, and your color frame, that piece of metal with a piece of gel or color filter in it, will slide right down into the top and sit in front of the light where the light comes out. Although this model of ellipsoidal reflector spotlight does not, there are many models out there that have that over-the-top little color frame holder clip, that safety latch, the same one that you saw on the Parcan. There are, especially when you get into brand names like Source 4 and Shakespeare, Altman Shakespeare's, you will see those safety latches on most of those types of fixtures to hold those color frames in. And now we get to the most important fixture of an ellipsoidal spotlight, and that is the shutters. Each ellipsoidal fixture has 4 shutters, and those are 4 handles that you can see on the outside there. On this side view, you can see that there are 3 visible, and those are actually thin pieces of metal that insert themselves into the fixture themselves. So what you can't see on the inside is that that's a piece of metal. It has a straight edge to it at a 90-degree angle to, or rather a straight up and down, so a plumb angle there, and then a level parallel angle there. So each of these is connected to one of those pieces of metal, and what that does is it actually blocks the light from going through to whatever it is you have the light pointed at. This is incredibly useful because you can point a light somewhere and keep it from shining in all the places you don't necessarily want it to shine. So say I have this light pointed at a piece of scenery, and the piece of scenery happens to be very close to the proscenium wall. If you remember the proscenium wall being the part of the stage that goes up on the sides and over the top of that stage entrance. So it's really close to the proscenium wall, and I don't want the light shining on the proscenium wall because that's not where I want the audience's attention to be drawn. So instead, I use one of these shutters and I kind of push it in to the point where the light cuts off just on the proscenium wall. It creates a shadow, technically, but because of where I've set it, because it's along the same line that the proscenium wall makes, the audience isn't going to notice the fact that it's there. These are awesome tools for the designers to be able to really focus in on the portions of the stage that they want lit. You can have some really cool effects with them if you really want like a box of light somewhere, but for the most part it's used for cutting off, quote unquote, light from various portions of the stage that you don't want it to necessarily be hitting. What's interesting to note about these shutters is that because there are two lenses within an ellipsoidal reflector spotlight, you have to reverse and flip upside down any image that you would be putting in here. So technically, this top shutter, if you were to start pushing it in, it actually starts cutting off the bottom portion of the light shining through. Same thing with the bottom shutter, that actually cuts off the top portion. If you push in the right shutter, it'll cut off on the left side, and if you push in the left shutter, it cuts off the right side. All of the actions you take with this light are reversed left to right and also reversed top to bottom. Which brings us to another super cool and useful component of an ERS, also ERS, ellipsoidal reflector spotlight. It's a much easier way to say it. So another feature of an ERS is what's called the gate. It can also be called the pattern slot. This little baby slot right here is in the top of the fixture, and that allows you to slide in another metal frame similar to the color frame holder, the color frame, but much smaller, and what it does is it holds what's called a gobo. A gobo is a small piece of steel that basically serves as a light stencil. So it has a pattern of some sort cut out into it, and obviously any of the cutouts are going to let the light shine through, while any of that steel that is still there is going to cause a shadow. You can get just about any type of gobo you could possibly imagine. They have gobos that look like trees, look like windows. You can get gobos that say words. You can get gobos that are just completely abstract patterns. You can get custom gobos. You can technically even get glass gobos that shine color as well. They're really pretty and very expensive, but give a really cool effect if you're able to have a good use for them. But there is no other light besides an ERS fixture that has that gobo slot pattern. Or, I'm sorry, gobo or pattern slot. So this makes this fixture incredibly unique between that pattern slot and the shutters. This is why an ERS is considered to be the workhorse of theatrical lighting. And now for the innards of an ERS fixture. We will start with the part that the fixture is actually named for, which is the ellipsoidal-shaped reflector. You can see this lovely portion right here. That is the reflector. And unlike the Fresnel, and more akin to the Parcan, you have your lamp not situated somewhere in between the hole of the reflector and the lens. Instead, you have your lamp located at the very tip, if you will, of where that ellipse would have its highest point, so that your lamp is as far back into that reflector as possible. So your focus point for all of the light coming out of it is incredibly far back, meaning that all of the light, again, that is given off of this lamp is going to be caught in the reflector somehow. You're not losing any light that is being cast in any direction. You will lose a little bit of light here and there by the light being cast directly this way, so it will not all the light being cast from that lamp will make its way to the lens, so you will lose some here. but all of that stuff from the back here and all the stuff from the sides is being caught by that reflector and pushed outward towards that lens. And what's interesting about this setup is that you then actually create two focal points of light coming off of this fixture. So you have the first focal point, which is actually the filament of your lamp at the back there, and as this ellipse angles all of the light towards the lens, you have a second focal point at the top there. And this is where the convex lenses come into play. What you're probably used to is seeing convex lenses used in the opposite way that they are being used in an ERS fixture. You're probably used to a magnifying glass, basically, where you have a very large beam of light, or an ambient light for that matter, say the sun or the light in your house, being forced through the convex lens and then focused down into a specific focal point. This is how you are able to take a magnifying glass with the light of the sun and burn the ants on the sidewalk. That's the hottest point of your focal point because you're taking that ambient light and focusing it down. But convex lenses also work in the opposite way, where you can take light with a specific focus point and push it through that lens, and from the opposite way will then create a nice large beam of light. And that is how an ERS fixture uses convex lenses. Now, in order to do this, if you look here, the convex lenses for what might be in a magnifying glass are both faced with the rounded part on the outside. On the other hand, you have two halves of that, basically, of this lens. So if you split this down the center, you would have the two halves that you see here, and they are reversed. So rather than the curved side being on the outside of that lens, the curved part is on the inside between the lenses. And that's what allows you to take this focal point and take it into a nice large beam of light. And you can even see a little bit where these arrows are pointing, where the light from that focus point goes out once, changes angle a little bit again, but then it changes angle even slightly more into a more defined beam, which is what that second part of the lens allows it to do. A few other things to note now that you can actually see the cross-section of this light is that you can see how far this barrel goes back. And that's the barrel that contains your lenses, and it allows the lenses to move back and forward via that adjustment knob there. So the lenses move back and forward with that barrel to create a larger focus distance, so that is the distance between the focal point and the lens, to change how wide or narrow that beam of light is. It's also important to notice that the gate, or the pattern slot, this right here, is behind the second focus point and in front of the first focus point. By putting it behind this second focus point here, it allows you, by adjusting the barrel, to adjust the clarity of the pattern that you are projecting. So by moving that barrel in and out, you can basically pull the pattern into focus. So if the barrel is all the way out, you might end up with something a little bit fuzzy, or you can pull it in and it might be a little more clear. But that also depends on how far away your object is. So if you have something really, really close, it would be a different setting to have a very clear, crisp pattern from that gobo than it would be from something really far away that you were trying to cast that light onto. So moving that back and forth allows you to change both the beam width as well as the gobo clarity. And having the gobo, again, behind that second focal point is what allows you to do that. Advantages to an ERS fixture. 1, they are incredibly versatile. With all of the different adjustments that you can make with this fixture, there is really no question as to why it is so widely used and so consistently manufactured by numbers of different companies. There are dozens of different models and makes, companies, etc. that make these fixtures. You could choose a couple dozen, literally a couple dozen different types of these fixtures and still never get one that has exactly the same build to it. Another advantage is that they are readily available. Because people use them so often, it is very hard not to be able to find one somewhere. A lot of the fixtures that we have in the attic theater are ones that were retired, quote unquote, from other theaters. They were donated to us, and they're still in perfectly good condition. They last a really long time. That's another advantage. All of the parts within them, although it is a little bit more complex to take it apart, all of the parts are individualized. So if something breaks, you don't have to toss the whole fixture. You can replace a single lens, a single lamp, a single reflector, etc., and not have to worry about chucking the whole fixture. Disadvantages, on the other hand, you end up with something that is incredibly complex. It's a lot harder to try and fix an ERS fixture than it is to try and fix any of the other ones that we have. There's a lot of moving parts, a lot of electrical parts, a lot of things that you really need to understand before you start trying to take it apart and replace or fix something. If you don't know exactly what you're doing, you probably shouldn't try to repair or replace something within an ERS fixture. Although they are incredibly versatile and incredibly widespread across the theatrical world, the problem with ERS fixtures is that they are the most expensive types of fixtures that we've talked about thus far. They're complex things, and in order to make something complex, you usually have to spend more money on it. So it is the most costly of the three fixtures that we've talked about. Definitely not the most costly across the board in terms of all the fixtures you could possibly find in a theater, but of these three main types, it will cost you a pretty penny more to buy an ERS than a Parcan or a Fresnel.